Okay. Okay, so now we switch to English. This tutorial will be seeing the Numpy library and also the matplotlib that is used to.
Could you please record the assistantship?
I'm already recording this and it's being uploaded to YouTube, so don't worry about that. Okay, as I already said, if you want to go with me doing the TA, you can open the Google Colab in the course page, and by using File Open Playground mode, you can start editing the Google Colab and start programming if you want. Okay, so the last basic Python thing that I wanted to see before going to Numpy is how to write and how to read a file. First, we'll start with writing a file. As we can see here, I'm defining the file name in a variable called file name. Then the syntax for Python 3 to write and read a file is the following: using with open file name. Here you have an instruction that tells the open function if the file is open in a write or read state. So you open this file as file, and then if you want to write lines, you, for example, can do a for loop that we've seen the last TA, and use the function write. This function write is a function that is inside the file object. That's why you need to do file.write. And here you basically start specifying a string of what you want to write. In this case, I'm writing numbers from 0 to 9. And we have already seen that this special character \n is basically an enter in the file. So if we execute this, we've already written the file called test.txt with the numbers from 0 to 9. Now, if we want to read this file, we do the same, but instead of specifying a W, you can either specify a R, that means read, or just do it like so without any specifier. And to read the file, what you want to do is a for loop. For line in file, here what I'm doing is printing each line. So if we run this, note that this file is the same as the one before with the numbers from 0 to 9. So the line number 0, it had a 0. The line number 1 had a 1, and so on. If we change the test file, so instead of writing 0, 1 until 9, we do, for example, 2 times I, and we use this reading function again, you can see that now instead of 0, 1 is 0, 2, 4, 6, 8. And you may be wondering why this quotation mark is right here and not right beside the 0. That's because we wrote at the end this special character that is the enter character. So that's why. That's why the quotation mark is right there and not at the side of the 0. Okay, any doubts about this? This for loop syntax is defined in the tutorial number 1. Okay, So if this is very new to you, you go back to the TA number 1 and you'll see how to write for loops. Basically what it does is, file here is a collection of lines, and basically what you're doing is assigning each of these elements to this variable line, and it's changing over time. For example, let's add another slide. If you have for a variable name in an object that has multiple elements, for example, the range object that we have seen in TA1, for example, from range 4, and we print the elements, we can see that the printed elements are 0, 1, 2, and 3. So this variable I iterates over this list or object that could be iterated. In the case of the file, this file, you can think of it as a list of lines. Line 1, line 2, line 3, and so on. And basically, each step in the for loop, you go first with the line 1, then to the line 2, line 3, and so on. Another thing that we've seen in the TA1 is this syntax here. This is called the string interpolation. And basically what I'm doing here is having the variable I and variable line printed in this format. The first variable I is printed as an integer, that's why it's %I. And the second variable is printed as a string, that's why it's %S, string. If we change, for example, this integer to f float, you can see that the line now is, the line number is a float. That means that it has decimals, in contrast to the first example that was only the integer part. Okay, maybe we can reduce the number of elements here so it's a little bit shorter. Okay, like that. And just a reminder, this from TA number 1. Okay, any doubts about what I've just said, or we can continue to the Numpy arrays? You can raise your hand in Zoom, just open your mic and talk, or the counter. Sorry, can you be a little bit more specific, Jorge? Oh, you're asking why you don't need a counter here? In this example? The for loop does not need a counter in contrast to other high-level programming languages, because the range object is already a list of 0, 1, 2, 3. So this variable I is assigned to each of these elements on the list. All the elements are already increasing by 1, so you don't need a counter. If you wanted to do a while loop, while I is less than 4, and you started I equals to 0, I plus equal 1. Sorry. There. Let me print something in between so it's clearer. As you can see, these two code blocks do the same. One is done with a for loop and another one is done with a while loop. The while loop, what it does is increase this counter. That's what Jorge was saying. Sometimes you needed a counter. So each iteration of the while loop is adding 1 to the counter. And also each iteration is asserting that I is less than 4. When this condition is not satisfied, the while loop ends. That's why you don't see a 4 here. If you put 5, it will go until 4. While loop. Okay, yeah, and this is the for loop. For loop and while loop. They do the same in this example. And there's another doubt about the reading and the writing of files, or the while loops or the for loops or whatever. It doesn't seem like it, so we'll continue. Okay, so in the previous TA, we have seen that just the list object in Python is not very friendly with some operations that we want to do usually in signal processing, image processing, or... Yes, Carla? Okay, I'll continue. So that's why it was necessary to create another type of object called Numpy arrays or numerical Python arrays that have a few benefits over the lists already present in Python. One of them is that you can do operations with them in contrast to lists. For example, here I'm creating an Numpy array using the function linspace that creates an array of numbers from 0 to 2. And we want, for example, 9 numbers in between 0 and 2, and this function creates that. So basically it's very handy to do it like that. But just to show the difference between the Numpy arrays and the common lists in Python, if we wanted to do the same, for example, from 0 to 4 with 3 elements, and we have 0, 2, and 4, we can do a list that is equivalent to this. 0, 2, and 4. And if we print the list, whoops, print, we can see that they are the same. But the thing that is not the same of Numpy arrays, this variable x and this variable y, a list, this is just a list, and this is a Numpy array, is that we can, for example, multiply each element by some number. In the Numpy arrays, we can do x times 2, and it works like you would expect. But if you do the same with a list, it will do something very weird. Someone know why this happened to a list? Why instead of multiplying each element by 2, it like did this? No? Nobody knows?
Maybe, hi Carlos.
Yes.
Maybe because how you define the variable in this case, when you print, it assumes that you should print twice.
Yes, that's exactly it. In the list object, the multiplication sign, or this times, does not mean multiply by a number. It means to replicate n times. That means that if we multiply by 2 a list, the list will be copied twice. If we multiply a list by 3, it will be copied 3 times, and so on. That's an example why Numpy arrays and lists are different. Here, a Numpy array, the multiplication symbol means element wise multiplication. So each element of the list or the Numpy array will be multiplied by 2. So here it was 0 to 4. So the numbers will be 0, 4, and 8. Another difference is, for example, if you want to erase a Numpy array by 2, the result will be what would you expect. Each element of this list will be raised to the power of 2. 0 is raised to the power of 2 is 0. 2 raised to the power of 2 is 4, and 4 is 16. So what happens with the list when you try to do the same? It gives an error. You can't do that with lists. So you have some operations that are not defined with the lists. Another one is, for example, the modulus. For example, let's change a little bit the list. Whoops, sorry. 8. Okay, so now in the Numpy array, I'm creating a Numpy array with the numbers between 0 and 7. Sorry, multiply this by a number. Okay, now you can see it. If you see x is 0, 1, 2, 3 until 7. We can do the same with the list. 3, 4, 5, 6, 7. So now, if we multiply by 3 or 2, whatever, you can see the same. In the second line is replicated list. In the Numpy array here, where I'm using the modulus operation, it gives me a 0 if the number is even, and a 1 if the number is odd. But if we're trying to do the same with a list, it gives you an error. So this does not work on lists. And
Carlos,
yes, Valerie?
when you use linspace, it returns a Numpy array of floats numbers, or
Yes.
is there a way to be integers numbers, or
Yes,
it is
there's a
always
way.
a float?
There's an optional argument in every NumPy function that is called the D type, that you can put, for example, as an integer, and now instead of a float, it's an integer array.
Okay, thanks.
By default, it's a float, but you can change it to whatever you want. You can even change it to a string, I think. No, it doesn't work. You can change it to multiple types: float and int. Like so. Okay. So how can you tell if an array is a NumPy array or a list? By doing this. If you just put x, you'll see that the output starts with array. Another way to do it is by using the type function. You use the type function x, you can see that it's a NumPy and the array. But if you try to do the same with the variable y, you can see that the x is a NumPy array, but y is a list. So that's the main difference.
I have a question. How do you just create an array, but like manually with the numbers you have to? I mean, because in the linspace here, just create a matrix with regular numbers between an interval that you give it. But if you want to control all the numbers of the matrix.
Yeah, that's a good question. An alternative way to do it, just by writing. Here I need to import array. This is another way to do it that is completely equivalent. If you do put here array, and you basically copy and paste this list, it's exactly the same. As you can see, the output remains the same.
Okay.
This is equivalent to write this. Sorry, starting from 0. There. You can write this or put a list object and it will be converted to an array. Any other doubt? Okay, so that's a function that is very handy, linspace. Another one is zeros. As the name tells, it just creates an NumPy array that it contains a certain number of zeros. In this case, it's 9. And obviously, there's an equivalent that is called the ones. I'm not sure if in the next slide I know. But yeah, there's also a ones function that basically what it does is to define a vector only composed by ones. Here we can see that x is 9 zeros and y is 9 ones. These are commonly used functions as well. Here I'm only showing the case of vectors, but you can also change this to a matrix, for example 2 and 3, and it will create a matrix of 2 rows and 3 columns. Okay, but for simplicity we'll just use the vectors. Okay, so another built-in function that works with NumPy arrays is the length function, just denoted by len. And if we call the len function to the previously defined array of length 9, you can see that the output is 9 as expected. This function is very useful if you want to iterate in all the elements of an array. For example, by doing a for loop, you can do for I in range and then length of x. And this will iterate len of x times. Oh, okay, so here this I have already said in the previous slides, but you can define a NumPy array by doing this also, just doing it by hand. The previous TA, someone told me, how can you get an element of a list or array? And this is called indexing. And in contrast to another programming languages, Python indexes start from 0. That means that the first element, let's put a comment here, the first element of this array is the 0th element. The second one is the first element, or the element with index 1. And then you have the element of index 2. So for example, if we do x2, instead of getting 4, you're getting the element 5. That's why it's printing 5. If you do -1, it will start from the end and going to the left. So if you do -1, you're getting the last element of the array. This is to get the value of the array, but if you want to set it or write this array, changing, for example, the second element to 8, you do just this. And now if we check the last element of the array, we can see that the element is 8 instead of 5. Yeah? Everything clear here, or do you want me to explain it another time? If you don't understand, you can just
can you
interrupt me.
explain it again, please?
Okay. Okay, if you're not understanding something, just stop me and say, can you explain it again? No problem with that, okay? We're friends, so we have trust in each other and we can do that. Okay, so I'll explain it again. An array is basically a list of numbers. Each number that you put in this like storage box has an index. An index is like the order in which the elements are saved. In Python, the first object, in this case 3, is represented by the index 0. The first one is the one with index 0. The second one is the one with index 1, and the third one is the one with index 2. To retrieve the value of x in a specified position, what you do is x, then use square brackets. This means I want to get the number in this position. In this case, the position of index 2. That means that we will get the 5 here. You can, for example, instead of 2, put 1, and you will get the 4. If you put 0, see now that we are getting the 3. We can also use negative index, and that means going from the right to the left. Okay, that's basically it. This is to retrieve the number in a certain position. That's why it's called like the get function. If you want to set or overwrite a number, for example, this 4, I want to change it to an 8. Instead of the index 2, I need to change it to 1. And then here I want to print the element with index 1. And as you can see, it's now changed to 8. If I print the x again, the x array, you can see that now instead of 3, 4, 5 is 3, 8, 5, because I overwrite the value in this line.
Sorry, what is the meaning of -1? What is the value?
Okay, so when you have negative indexes, what you're doing is instead of going from left to right, for example, here is 0, 1, 2, it's the opposite. The last element is the element with index -1. And this one is the one with element -2, and this one is the one with element -3, like this. So if I put the negative index -1, I'm getting 5. If I put -2, I'm getting 4. If I'm putting now -3, I'm getting this 3. So for example, -3 also works and is printing the number 3. If I put -2, I should be getting the 4. So it is correct. And in particular, if I do -1, I'm always getting the last value of the array. That's why I'm using this as an example, because it's very common for one to want to retrieve the last element of the array and the first. With this you get the first, and with this you get the last element of the array.
Thank you.
I have a doubt, Carlos, because I would have write 0, -1, and then -2.
Sorry, can you repeat the question?
I would have write 0, then -1, then -2.
Your question is why
Yeah.
it does not
Why
start
is
from
it
0 here?
Yeah,
It begins
that's my
with
question. I have that.
-1.
You need to imagine that when you use an array like this, instead of thinking it as just one array, it's like 3, 4, 5, and it has another part that is the one in reverse. For example, 5, 4, 3. So if you use indexes with positive or 0 index, you are getting these numbers, 3, 4, and 5. But if you're trying to do negative indexes, you are getting the vector in reverse. You're getting, sorry, this should be a 5. This should be a 4. So with indexes that are greater or equal to 0, you get the usual elements of the array. The first one is 0, the second one is 1, and the third one is 2. But when you go to negative indexes, you start getting them like from the end. That's why it's -1, 5, -2, 4, -3, 3. I'm not sure if that makes it clearer or confusing.
Okay, makes sense. Makes sense. Thank you.
So basically you have the index here and the value here. And the positive indexes are the normal array, and the negative indexes are the array like flipped, or you can think of it like that. Okay. Another problem that arises when you use Numpy arrays instead of just common lists is that you need to be very careful when you use them, and specifically when you want to copy them. For example, here I have my vector x that it was 3, 8, 5, right? And I'm assigning y as being basically the same as x. And if you print y, you get the same, 3, 8, 5. And this is a very counterintuitive thing to do here. If you modify the first element of y and you overwrite the value, so instead of 3 it is now a 0, what do you think it will happen to x? There's two options. X will remain the same, and it will change with y. Have option 1 and option 2. What do you think? You can vote on the Zoom chat if you want. I will be repeating this. I am changing the first value in the array y. Will x change or remain the same? Let's start seeing the votes. It does not need to be correct, just what you think it will happen. Here I have the votes. So Cristina think this x array will change. Felipe thinks it will remain the same. Jorge thinks it will remain the same. Come on, just Carla, it's going to change for x, and for y it's going to be the same. Okay, that's a third option that I didn't consider. That it will not change the value in y, but it will in x. Carmen think x will remain the same. Paola, what do you think, for example, on this example? I said example twice, sorry. The same, it will remain the same. Alejandro, I think it will change. Let's see. Most of the people think x will not be affected by a change in y, right? That would be the intuitive case. So if I run this cell, as you can see, x is actually changed by modifying the first element in y. Can someone guess why x did change? And just to cover all the cases, y also did change. Okay, so the first element in y was also changed to 0. Because the copy function affected both. And the copy function is not being used here. I'm just doing y equals to x. Alejandro, because it references the same object. That's exactly why. X is an object. Okay? They use the same. When I'm doing y equals to x, I am not copying the values of x. I'm assigning y as the same object as x. Right? I'm referencing the address in memory. So if I change y, I'm also changing x, because they are the same object. This problem is very hard to debug if you don't know that this could happen. That's why I'm telling you here. You need to be very careful using NumPy arrays, because when you do something that it should be just copying the values, you're actually assigning the whole object. So if you change, for example, y in another part of your code, x will also change, and it will give you very unpredictable results. Severin asks if this happens with the lists. That's a good question. We can test it here. For example, if we define x list as the same values 3, 4, 5, sorry, 8, 5, y list is equal to x list, and we print also y list. let me redefine x. Okay, so now x is 385, y is a copy of x, y list is a list with the same elements, and now let's see what happens when I modify the y list object. What happens to x list, right? So as you can see here, it also changes. An array is mutable. Yes, you can change an array. Is this happening with lists? Yeah, so it happens with arrays and also with lists. I thought that this would not happen with the list, but I think it also happens. Okay, so how you can prevent this? By using the copy function. So if instead of doing y equals to x, we do y equals to a copy of x. Let me change the numbers again. So y is 385. Now if I do a change in y, x remains the same. But y is changed to what you should be expecting by doing this. Okay? It's a little confusing if you don't have the concept of object and others in memory. But just be careful when you're trying to assign a Numpy array to another variable. Always use the function copy. Always use the function copy to avoid problems. This actually happened to me once I was coding a very complicated function, doing finite elements and stuff that is very some algorithm that required a lot of lines of code, and by changing just another variable, my main variable was changing, and I didn't know why. And then I googled and searched in Stack Overflow. That is a very good website to search about Python problems, and they said exactly this. So you need to be aware that the Numpy array is an object, and if you do this, you're basically assigning the same object. You need to copy the elements to be safe. That is the main point of this slide. Okay. Another thing that is very similar to indexing is slicing. Slicing an array. For example, you have this array, x, with elements 11, 12 to 16. Let me copy this so we can visualize the index numbers. So the first element, 11, is 1. Sorry, is 0. This one is 1. This one is 2. This one is 3. This one is 4. And this one is 5. So what happens, or how we can, for example, select only this part of the array? That's why we need the slicing. If I specify x equals to this part of the array, to a vector y, look what I'm getting. From 1 to 5, that means from 1 to 5. And someone can tell me why it's not including the 16 here? If I'm specifying from 1 to 5, why it's not including 16? Well, the answer is because in Python, the end is never included. In the first TA, we saw a function called range, right? And we saw that, for example, if I do range 3, I obtain the numbers 0, 1, and 2. But the last element is never included. It's the same with indexing or slicing. And if you put 2 dots, and if you put another one, okay, from 1 to -1, then, sorry, let me see. With 5 is until 15, and -1 is the same. You can think that -1 is the same as 5, basically. Okay, so the end is never included. Jorge, do you have another question? No? So you can think that 5 is the same as -1. So you put 5 here or -1, it will give you exactly the same results. The same here, 4 is equal to -2, and this is -3. So if you want to write it in a very confusing way, you can write it from, instead of 1, you can write it from -5 to -1. And it will be the same, but in a very non-intuitive way. So it's best to use positive indexes. Okay, so Jorge asks how to include the 16. You need to do instead of 5, 6. So for example, if the length of this array is 6, you need to go from 1 until the length of x. Be careful, because if you do one number more, okay, it seems that in Numpy arrays it does not give you an error. It works. I think it lists, this will throw you an index out of range. Okay, let's continue. Two-dimensional arrays or matrices, and as I have already told, you can use these functions, zeros, ones, and so on, specifying a tuple or group of numbers, pair of numbers, in which the first number will be the number of rows and the second number will be the number of columns. So for example, if you want to define the identity matrix, first you define I equals to zeros of size 3 rows and 3 columns. Then the indexing in a 2D array is the same as the one in a 1D array, but the first element in the square bracket represents the row and the second one represents the column. So for example, if I want to modify this number of the array, I need to modify I equals to 1. This is the row with index 1. and the column with index 0. For example, this equals to 2, and now I am modifying this number here and writing a 2 in that place. If I want to modify this number, which index I will need to use? Which pair of numbers define this position of the 2D array? Okay, so this is the row number 1, this is the row number 2. So the intuitive way of thinking it is that this would be the 2, 3. But in Python, we start from 0. That's why we need to, instead of doing 2, 3, using 1, 2. For example, if I want to change it to 6, as you can see, I modified this element, overwriting the value 0 and changing it to 6. Another very useful notation is the double dot notation. For example, I have 1, comma, and just this, it will change the whole row to 6. If I also do the same, but instead with the double dots here, and I change it, for example, to 7, I will change the whole column to 7s. So this is something you need to start thinking about in the index space. Okay, so but with our easier example, we just need to modify the diagonal with the ones to make the identity matrix. Can you change the whole diagonal? That's a good question. I think you can. You can by doing let me see something. No, it doesn't work in Python. Yes, you can change it by doing this, I think. No, it didn't change. It modified the whole thing. If instead of this, I use 1, 2, 3. 1, 2, 3. Sorry. 0, 1, 2. 0, 1, 2. Now it works. So to change only the diagonal is a little bit more complicated, but you can do it as well. Here you're specifying the coordinates you want to modify. You want to specify the 0, 0 coordinate, the 1, 1 coordinate, and the 2, 2 coordinate. Yes, the first element is always the column. So to remember this, I will write it as a comment. The first element before the comma is always the index of the column. And this one is the index of the row value. Can you express the coordinates in terms of a function? Can you elaborate a little bit more in that example? A function like what, for example? maybe just to give an example, this part here, while it needs to be an index, there's no problem in using a function here. You can use the function 1 that you previously defined that outputs a list of columns, and another function 2 that you defined that outputs a list of indexes for the rows. For example, the range function to change the angles or okay, that's a good point. Yes, to generate those lists, I think you can do it with the range. Maybe it will not work. Let me see. Yes, it also works, because basically this range is the same as doing 0, 1, 2. So it's another way of writing this. For example, okay. So if we now want to define the multiplication between this matrix, this identity matrix, and the arbitrary vector x 1, 2, 3, what we can do is to use the function dot that does the matrix vector multiplication or dot product. The identity matrix, by definition, it will not change the output of the output vector. So if we do this, the vector y will be exactly the same as the vector x. If you, instead of multiply by the identity matrix, you multiply by twice the identity matrix, you will get each element multiplied by 2. So in this case it would be 1 times 2, 2 times 2, 3 times 2. An alternative notation of the dot product in Python 3, this only works for Python greater or equal to 3, is that instead of using the dot function, you can use I at x. This does exactly the same. I think this is a little bit more clear than using the dot function. So if you want to do the dot product, prefer doing this instead of using the dot function. Same as dot. Okay. If you do not know what the dot product is, don't worry, you will be seeing it in the next lectures and the next TA. No, the TA after the next one. We'll be seeing more examples with 2D arrays or matrices, and we'll be using this dot product further. Okay, as I already told you, by default the Numpy arrays, when you do the multiplication, what it does is an element-wise multiplication. So it will multiply the numbers of the list together. So here we have 1, 2, 3, and 3, 5, 8. The result of the first element is 1 times 3. The result of the second element is 2 times 5, 10. And the result of the third element is 3 times 8. That is 24. When you try to do this with a list, it will not work. This will not work with lists. And this is different than other languages, for example, MATLAB. In MATLAB, when you do just the multiplication symbol with two vectors, instead of doing this, it will do the dot product between the two vectors. Okay, so it's a little bit different between Python and MATLAB. So be aware of the definitions of the operators for each language. Okay, so just to show more, you can also do the matrix multiplication or dot product by using the multiplication symbol. If instead of using an array element or object, convert the array to a matrix object. When you do operations between matrix objects, then this multiplication symbols becomes the dot product. That is more similar to MATLAB. Okay, so another thing I need to show you is a little bit more about the linear independence of vectors. As you have already seen in class, by definition, a set of vectors x1 until xn is linearly independent if the summation between all of them, or the linear combination, is equal to 0 only if these coefficients alpha are exactly equal to 0. And this is a very mathematical combination, definition, but if we wanted to see this in a plot, for example, here a1, a2, a3 are 3 vectors that are linearly independent. As you can see here, sorry, I forgot to run a cell. To run this hidden cell. Okay, so now you can see that if we have the vectors a1, a2, a3, we have 3 arrows that are orthogonal to each other. And if you want to visualize how a linearly dependent set would look like, it would be something like this. So for example, if we define a vector a equals a4 equals to a1 plus a2 minus a3. Now let's remove the a3. And we multiply this by 0.5, or better, square root of 2. I didn't define the square root. I can do the power of 1/2, like so. Instead of a3, I put a4. You can see how it looks. So the vector that was first pointing upwards is now in the same plane as the vectors a1 and a2. This vector that is in between, the vector a4, is linearly dependent to a1 and a2 because it can be expressed as a combination of both with coefficients here that are not equal to 0. Here, the coefficients that I previously called alpha are not equal to 0. So basically, when you have a n-dimensional space, a set of linearly independent vectors will point in all the directions of the space. But if instead the vectors are linearly dependent, the vectors will be contained in a subspace of the that space Rn. In this case, a plane that is all the linear combinations between a1 and a2. So a4 is contained in the plane defined by a1 and a2. But when you have more vectors or more dimensions, it's not as easy as just plotting the vectors and seeing if it's inside a subspace or not. So there's a more programmatically way of doing this by importing the function matrix rank. If I do the same with the first set of vectors, a1, a2, a3, that we know that are linearly independent, the rank of this will be 3. That is the same, rank 3 is equal to the dimension of the space. In this case, also 3. But if we have linearly dependent vectors, the rank in this case 2, will be less than the dimension of the space, that in this case was 3. So with this rank function, you can see if the vectors are linearly independent or linearly dependent. Okay, so I don't have time to show the plotting functions, but try to finish the TA, the part of plotting functions. We have a lot of examples here, and I'm interested in this activity. Please try to finish this activity, the activity 1, for the next TA, so you can practice a little bit plotting functions. If not, we can see it in the next TA. Will you upload the notebook 02? It's already uploaded in the site. The last thing I wanted to talk was about the homework 1. So the homework 1 was already posted, and we need to define a date for the next TA. So I'll stop the streaming and we can talk a little bit about that.